Okay, so what I'm going to do is show you how to do 5e. This particular proof is a little lengthy and complicated, so we wanted to give you a video to help you with this. Alright, so as I always tell you, you need to have a plan for your proof. So my plan is that I am going to prove ACP congruent to PEG. That way I will be able to say that these two angles right here are congruent. Then, because the angles we are wanting to prove congruent are linear pairs to these congruent angles, then I'm going to be able to show that they are also congruent. So, let me erase this. As you can see, I've taken out a couple lines from the picture. I thought that would help you see in the video the triangles better. Alright, so here we go. So our first statement is going to be that DP bisects AG. I know that because it is given right up here. Next, following from that, AP is congruent to PG because DP bisects AG. We know that bisects means that it's cutting it in half. So that's the definition of bisector. All right. AC is congruent to AP. This is a given. So if AC is congruent to AP, we also use one mark on the figure because we've already used one dash for AP. So remember, we use additional dashes when they're not congruent to what we've already done. Okay. GP is also congruent to GE. This is also a given. So we're able to now mark over here. So actually all four of these angles are congruent. All right. Next, angle CAP is congruent to angle PGE. I know that because you have just completed 5D. And in 5D, you proved that triangle DPA was congruent to triangle DPG. So this is actually CPCTC. Corresponding parts of congruent triangles are congruent. And again, since this is the same problem, same situation, same givens, I'm building on that proof from before, so I can actually use that proof. Next, I now know that PAC is congruent to triangle PGE, and I know that from side angle side. So if you look up here on the figure, oh, I forgot to mark that one. So those are the angles that we just proved by CPCTC. So now what we have is triangles that are congruent to each other. From that, I can now say angle ACP is congruent to angle GEP. That is by CPCTC, corresponding parts of congruent triangles are congruent, because angle ACP and GEP are parts of the triangle that the pair of triangles that we just proved congruent by side angle side. So again, I'm marking that on the figure to help us. Now remember that the first part of my plan was to make these congruent so that I could say that those two angles that are in linear pair relationships with the angles we want to prove congruent. That was my first piece. So now my second piece is to use this linear pair postulate and the linear pair relationship we have going on here to actually prove that the triangles we're wanting to prove are congruent. So I can next say the measure of angle ACP plus the measure of angle PCD equals 180. That is because of the linear pair postulate. Similarly, I can say the measure of angle GEP plus the measure of angle PED equals 180 degrees for the same reason. So thinking back to our figure, what I've just said is these two angles, because they make a linear pair, add up to 180, and these two angles, because they make a linear pair, add up to 180. If they both equal 180, then what I can say is the measure of angle ACP plus the measure of angle PCD equals the measure of angle GEP plus the measure of angle PED, and that is by our good old substitution. Remember that back in the day, and in one of our previous units we used that quite a bit. Then what I'm going to do is I'm going to subtract from both sides angles that are congruent. So the ones I highlighted here in that teal color, those equal 180, those equal 180. But we already knew that these two angles were congruent. So if I take that and subtract those congruent angles out, then what I will have left is the angles I want. So next step, measure of angle PCD equals the measure of angle PED. This is by the subtraction property of equality. And again, that's because angle ACP is congruent to angle CEP. We said that up here. So if I subtract both of those out, I'm subtracting equal amounts out. So we're not quite there yet. It almost says what we want it to say. We don't want it to say the measure of these angles. We want it to actually say these angles are congruent. So because of what congruent angles are, we can say the angle PCD is congruent to the angle PED, and this is because of what the definition of congruent angles is. And now, ta-da! We have finally gotten it to say what we want, and our proof is complete.